Hello guys, today let's talk about Gausses law. It states that the normal component of electric field means electric flux over any closed surface and any shape drawn in the electric field is equal to 1 by epsilon naught times the equal magnitude of charge enclosed by the surface. So for this, let's talk about electric flux first. I've drawn a figure. This is electric field from right to left, left to right. Left to right, the electric field is from left to right, and there is I have drawn a plane uh, whose area is A. If electric field is going from left to right and the plane is here, as you can see, then d phi means our flux is equal to E into dA. E means electric field and dA means area, small change in area. So this is the formula of electric flux. Electric flux is uh, defined as the uh, electric field and the area of the object in the field. Uh, you know, as you can see from figure here, theta is 0 degree, so we can say cos 0 degree is 1. So d phi is equal to EDA, which is maximum. And now we can understand this. Like it says that the normal component of electric field over any closed surface. Uh, you can say normal component of electric field as flux, outward flux. It states that the outward flux um, over any closed surface and any shape drawn in the electric field is equal to 1 by epsilon times the total magnitude of charge enclosed by the surface. Now let's understand this. Okay, let's look at the derivation of Gauss law. First, we have to make sure there is charge which is enclosed by a surface. This is plus q charge which is enclosed by a surface, yes, and we consider a small area. Okay, this is the area. Let's call ds the area, and there are two field. Okay, like this is e vector and this one is normal component, and whose angle is what we call it, theta. Let's assume it theta. Okay, phi is electric flux, and now we can say that this the electric the normal component of electric field E vector over the closed surface S is given by, okay, we can write it, which is given by cyclic integral E vector dot A vector n cap E vector dot n cap ds, okay, which is flux. Okay, I told you flux is normal component of electric field E vector over the closed surface, and but electric field intensity is given by E vector is equal to q by 4 pi epsilon naught r vector by modulus r vector whole cube. Then we can write this equation 1 by substituting the value of E vector. We will get phi is equal to electric field q by 4 pi epsilon naught r vector by modulus of r vector whole cube into n cap ds. Okay, now what we're gonna do is we know that the quantity r vector by r, this r vector by r modulus dot n cap or n vector dA ds, this quantity, this quantity gives the projection of area, gives the projection, okay, projection of area ds on a plane perpendicular to r vector. Okay, this projection area multiplied by 1 by r square is solid angle. If we multiply it by 1 by r square, then this is solid angle. So if we multiply it by 1 by r square, then we can get solid angle, which is d omega. So here we can write r vector dot n cap ds is equal to d omega. We multiply it by 1 by r square and we get this. Okay, sorry, this is cube. We here is cube, so this whole term becomes d omega. So now our equation becomes like phi is equal to uh, cyclic integral q by 4 pi epsilon naught d omega. Phi is equal to, we can take out q by 4 pi epsilon naught into cyclic integral d omega, and integration and derivative get cancelled. So q by 4 pi epsilon naught, which is omega is 4 pi. 4 pi cancels, so phi is equal to q by epsilon naught, which is the required relation or derivation of the answer. And this is the required answer. Okay, this is epsilon. Electric flux is equal to charge upon epsilon naught. This is Gauss law. And then now we will see Gauss law. If the charge is outside the surface, okay, we see charge when it is inside the surface. So Gauss law is only applicable when charge is inside the surface. When charge is outside the surface, we will see and we will get that the electric flux will be 0. Let's see. You see, I make a figure. There is some illegal thing, and the charge, is outside here. This is Q charge. And now the normal component, we already know that the normal component is phi is equal to integration E vector dot ds, or you can put phi here, which is equal to 0. Okay. For the normal component of surface area at S1 and S3, we see S1 and S3. The normal component here are away from the charge S2 and S4, which are away. So component of surface area are towards the charge. This S2 and S4 are towards the charge, but S3 and S1 are away from the charge. And the contribution of pairs of component of surface area S1, S3 and S2, S4 are equal and opposite. So surface integral of both are cancelled to each other. Okay, both surface integrals are cancelled to each other. Hence, we can say cyclic integral E dot ds vector is equal to 0. Okay.